Hey Coding Club, this tutorial is the start of a 2D platformer series on Unity. In this video, we are going to be setting up the Unity project and implementing basic movement. Remember, if you have any problems following this video, feel free to reach out. This tutorial assumes that you have no Unity experience and basic C# or C++ knowledge. If you are new or have forgotten some of the content, reach out to us. We'll help you catch up. Okay, so to get started, open the Unity Hub. If you haven't installed Unity already, watch this video to catch up. It's going to be linked in the description. When you open the Unity Hub, you should see something like this. To create the project, press New and give the project a name. Then select the 2D template option and press Create. This initialization process takes a few minutes. When you're done, you should see something like this. This is the Unity editor. Right now we are in a scene. In order to move around the 2D scene, hold the middle mouse button down while moving the mouse. Okay, let's create a basic character and ground object. Go to the top left corner and click Game Object, 2D Object, Sprites, then Square. We need to make two of these. Drag one of the squares down a bit and stretch it out. This is going to be our ground. Now, in order for objects to touch each other, they both need the Collider 2D component, which will give the objects hitboxes. Go to the inspector, press New Component, and type in Box Collider 2D. The reason we don't use the regular Box Collider component is because it's meant for 3D objects. We also need to set the layer of the object to ground. I'll explain why this is important later. Go to the layer dropdown, press Add a layer, and in one of the empty boxes, type in the word ground. Click on the ground object again and set the layer to the one you just created. Now, let's work on the player. Click on the square object and rename the object to Player. The player object will need a Box Collider 2D component. We also need to add a rigid body 2D component. The rigid body component gives the objects physics. If we don't have the rigid body component, the player would just float in the air. Now, set the collision detection of the rigid body component to continuous. Otherwise, the player may phase through walls when going too fast. Okay, we can finally start programming. Let's create a new script and name it player_movement. Double-click on the script to open it in Visual Studio Community. If for some reason you don't have the community version, watch this tutorial to learn how to install it. Let's examine the code template Unity gives us. At the top, we can see a few libraries imported for us already. You don't need to understand their purpose yet. Under the libraries, you can see a class with the same name as your script. If you don't fully understand what classes do just yet, don't worry, we'll explain it in a future video. However, it is important to note that all functions and variables in the script need to be written inside the curly brackets of the class. We can see two functions written for us already, start and update. Let's start by making a few variables. We're going to make a float named speed and set it to 10f. The const keyword means that the variable cannot be changed later. The f behind the number 10 means that the number should be treated as a float. The f here isn't necessary, but it looks cool. We also need to declare an instance of the RigidBody2D class. Let's call it RB. Remember, RigidBody2D is the component that gives objects physics. Inside the start function, we need to set RB to the rigid body component inside the player object. We can do that using the getComponent method. And what this method does is that it goes through the object that contains the script. It looks through every component until it finds the rigid body 2D component and then returns it to the variable. We also want to have a float that stores the user's horizontal input. I'm going to call mine input x. In the update function, we want to set input x to the result of input.getAccessRaw horizontal. Input is a Unity class that has many attributes, one of them being getAccessRaw, which gets the raw input of the user as a value between -1 and 1, depending on the keys they press on their computer. Okay, let's convert the input into movement. On a new line, we're going to set the horizontal velocity of the player to the horizontal input. Let's go over the syntax of this code. RB.velocity determines the player object's velocity. Note that the velocity is of type vector2. This means that if we wanted to change the value of the velocity, the new value would have to be of type vector2 as well, the same way that a string variable can only be set to the string data type. In this scenario, the new keyword is used to instantiate a vector2 object. Vector2 is a Unity struct that is used to represent 2D positions and direction. In this example, we are using it to define the horizontal and vertical velocity of our player object's rigid body component. The first argument is used to define the x velocity. We've set that to the x input multiplied by the player's speed. The second argument determines the y velocity. Since we don't want to change the y velocity in this line of code, we're going to set the y value to its current y value, which means that the y velocity is unaffected. Save your file and test the game. We should now be able to move the character around using the A and D keys and the left and right arrow keys. If your character doesn't move, you probably forgot to save the script before launching the game. Notice how our character spins when hitting the edges. We need to lock the player's rotation. Stop the game and click on the player. Inside the rigid body component, find constraints and lock the player's Z rotation. It's very important that you stop the game before making any changes to your player, because any changes you make while the game is paused or running will not be saved. But if you run the game again, the player now moves normally. Just kidding. We have another problem. When we hug the wall, the player stops falling. This is because the player object has friction. To remove friction, stop the game again and navigate to the Project tab. Create a new 2D physics material. I'm going to name mine Frictionless. Set the friction of the material to 0. Click on the player object, navigate to the rigid body, and drag the frictionless material into the material input. Now if you run the game, the character no longer sticks on walls. Okay, time for the jump function. Let's create a new float and call it jump velocity. This is what we want to set the velocity to when the player jumps. Go back to the update loop. We can check if the jump button has been pressed using the get button down method of input. And whenever the jump button is pressed, we want the player's y velocity to be equal to the jump velocity. Now if we run the game, whenever we press the space button, the character jumps. There are two problems to fix. First of all, we don't want to bind the jump key to the spacebar. We want the player to jump when we press the W or the up key. Go to Edit, Project Settings, Input Manager, and the first jump option. Don't click on the second one, it's meant for something else. Change the positive button from space to W and the alt positive to up. If you run the game again, you can now use the WASD and arrow keys to move around. You may notice that the player's gravity seems to be falling a bit too slowly. Let's change the gravity to 3. We have a problem. The player can jump whenever they want, making the game feel more like Flappy Bird than a platformer. Let's modify our code so that the player can only jump when they're touching the ground. Declare a variable of type layer mask with the keyword serializedField. Name it ground layers. The serializedField keyword is used to make private variables show up in the Unity inspector. The layer mask struct is used to specify a list of layers. In this case, we're going to be specifying what layers are considered ground. We also need to declare a serialized variable of type transform, and we'll call it groundCheck. The transform class in Unity stores the position, rotation, and scale of a given object. We are going to use the transform class to store the position of the player's feet. Save the file and go back to the Unity inspector. Right-click the player in the Hierarchy tab and create an empty child. Let's name this object groundCheck. Under the transform component of the inspector, change the empty's y value to -0.5. You can now see that the empty object is directly under the player object, and since the empty game object is a child of the player object, the empty will always follow the player around and always be at the player's feet. Click on the player object and scroll down to the player_movement script component. You should see the two variables we serialized earlier. Drag the groundCheck object into the input for the groundCheck transform. Unity will take the transform data of the game object and give it to the script. Go to the ground layers dropdown and select ground. This was the layer we set the platform to originally. Let's go back to the script. Under the update function, make a new function of type bool named groundCheck. When called, this function will return true if the player is touching the ground. Otherwise, it will return false. Inside the groundCheck function, type this line of code. Okay, let's break down this line of code. We are first making it an array of type Collider2D named colliders. Remember, colliders are the component used to give objects hitboxes. The two square brackets behind the Collider2D keyword makes the type an array. An array is basically a collection of variables that have the same data type. In this case, the data type would be Collider2D. We name this data type colliders, and we set the array to the return value of the overlap circle all method in the physics2D class. Looking through the Unity documentation, we can see that this method gets a list of colliders within a circular area and returns the result as a Collider2D array. If you look at the parameters of this function, you can see that it needs a point, a radius, and 3 optional parameters. We will be using the first 3 parameters. If you go back to the code, it all makes sense now. We are drawing a circle at the player's feet with the radius of 0.1 units and returning any colliders with the ground layer. Notice that if there are no ground colliders within the circle, the method will have nothing to return and will return an empty array. Therefore, as long as the size of the array is greater than 0, we know that the player is touching the ground. The cool thing with arrays is that in C# you can check their size using the .length property. So, if the length is greater than 0, we return true. Otherwise, we return false. Now, let's modify the jump if statement to require the player to be touching the ground too. Save the file. And with that, our player can now run around and jump in our Unity game. As homework, I want you guys to add a double jump feature to this game. We'll go over the solution next week, but there will be prizes for anyone who finishes early. If you guys have any feedback for this style of video or would like to learn something specific, message me on Discord or comment your thoughts below.
Bye bye.